Hello, everyone, and good evening, good afternoon, and good day. We are here for another episode with your girl, Audrey Codner from ACG Math Tutoring. Hopefully, everything is going well for you. If you are here to kind of brush up on a little bit of Algebra 1, Algebra 2, just trying to find a new way to get yourself started up and moving, well, then this is the place for you. All right. Hello, Kathy. Hello, Supreme Eyes. Hey, Mama. How's everyone doing? So we're going to continue on with our series. Let me see if make sure my volume is up and ready to go. All right. So we're going to continue our series with this rational expression. Yes, there is a lot to this. So first we did simplification. Then we kind of looked at multiplication and dividing. Remember, dividing is that keep, change, flip. And right now, we're going to continue on this process. And we're going to actually see if we can do some more simplification when you have like term denominators. So basically, remember, a rational expression is just basically a fraction. But your numerator and or your denominators are polynomials. So you're going to have to do some factoring. And after you do some factoring, you take a look at the products to see what you can cancel out or eliminate based off of what's in the numerator, and the same thing is in the denominator. So we're going to be looking at a little bit with like denominators. And if we have some time, which I think we will, we're going to look at unlike denominators. So keep in mind about fractions, all right? So let's start off slow. Slow, low, and in control. So we have 3n divided by 12. You're like, oh, we can reduce that. Stop it. 7n over 12. All right. So these are rationals, okay? We got fractions and we have common denominators. Now, just like if it was a regular fraction without the variables, when you have a common denominator and you're adding and subtracting, the only thing that you are keeping is your denominator. So we're going to keep our 12. But then what changes is we're going to combine our numerators. So 3n plus 7n gives me 10n. Now, since 10n is the same as saying 10 times n, and 12 is the only thing that's in your denominator, we can simplify. All right, I'm not going to say because we actually have two monomials right here and we can actually simplify that. So what 10 and 12 have in common is 2. So that 10 is going to turn to a 5 because 10 divided by 2 gives me 5. This 12 is now going to be a 6 because 12 divided by 2 gives me 6. So my final answer is going to be 5n over 6. Okay. All right. Let's see who's here. All right. Oh, everyone is here. Good. Kathy is here. Daniel, hello. Good night. Michael R. It's always a pleasure. Sandra, hello. Amanda, thank you for the follow. Bestie 999, how are you? Good job. And I think you reduced. Yes, you did. Good job. Good job, Daniel. Nice. Okay. AK Blue Eyes 56. Good job. Nice job, guys. So proud. Hey, Pops. You guys, you definitely should follow Pops. Pops is such a cool guy. I haven't seen him for a minute. I'm so glad that you're able to stop in. Thank you. All right, so we're going to break down even more. So we're going to go through stuff nice and slow, okay? So again, if you are new to my space, 1, welcome in. 2, this is how I do math, Okay, we probably had some kind of trauma in our life that a math teacher or a family member or someone told you that you're too stupid to understand math. And this is where I'm going to try to break that cycle so you can see, hey, this is not that bad. So notice the atmosphere is nice and cool and chill. And this is just how we do things here. So if it's a little too slow and you're like, oh, well, can't we move on to the next one? Well, guess what? This is how I do my thing. Okay? This is what happens here. So if it's too slow, you can always leave. I love you. I would love for you to stay. But I really want people to feel comfortable with being in this atmosphere. All right? So let's look at another one. So we have 10x minus 12 over 2x minus 6 minus 6x over 6 minus 2x. Ooh, she got a little technical with this. Okay, here's Roy. I swear, Roy and Michael. Do another. I will. Okay. Telling you. All right. So we're going to break this down step by step. If you think you got it and you want to move forward, go right ahead. All right. Good, bestie. That's exactly what we're going to do. We are going to factor, but let's take it at one ratio at a time. So I'm going to cover up this first one. I'm going to cover up in 5, 4, 3, 2, 1, just in case you wanted to copy down. And I'm going to zoom in. Okay. I feel like sometimes I need to say these things before I just up and do it. Okay. So now we are going to break down. Let's take a look at our numerator. So we have 10x minus 12. What do they have? Where was I 2 weeks ago? I was here. I just didn't crawl up on your FYP. All right. So 10x minus 12. What is my GCF? Always ask yourself, do I have a GCF? All right, bestie 999 is saying 2 times x minus 3. In common, fit saying 2 in common. Des is saying -2. Hey, Des. The buy more store saying 5. Bestie 99 saying 2. Daniel saying 2. Okay, I used to be really good at this. Now I'm quite useless. All right, 1. You're not useless. All right, we're not going to have that talk around here. I don't tolerate that. So we're going to change that mindset and just say, it's been a minute. I'm welcome to receive. I just want to sit here and chill. All right. Much love, darling. All right. So now we do have a 2 in common. So I'm going to factor out that 2. And what's left is going to be 5x minus 6. All right. So 10 and 12, they both have 2 in common. They're part of the 2 times table. So when we factor out the 2, what we have to get, what remains inside, is we take the original and divide it by what's called our greatest common factor. All right. 10x divided by 2, that's where 5x came from. Negative 12 divided by 2, a negative divided by a positive gives me a negative. That's why that's a -6. Now, in the denominator, down in the bottom, 2x minus 6. All right. What happened to KCF? True. Okay, Manuel, that is true. But remember, we can factor, okay, because right now we don't have a common denominator. All right. We do not have a common denominator. So if we're going to be adding or subtracting, we need to have a common denominator. All right. Before we were multiplying and dividing. So when we multiply and divide, we don't have an operation in between. Okay. That's the slight difference. All right. So I'm seeing, okay, 2 times x minus 3. All right. So Sandra, I saw your second one. Good job of correcting. L Josephine or I Josephine, 2 times x minus 3. Bestie 999, 2x minus 3 in the denominator. Good. Yep, I saw your change. All right, excellent. So they had 2 in common. Then we have x minus 3. All right. So now, coming over to the other side. Okay. Dropping our minus sign. And coming over to the other side. Now, the numerator basically staying the same. It's just 6 times x, so that works with us. So I'm just going to put 6x here in the numerator. But what's happening in the denominator? Right? It is kind of fun, right, El Josephine? That's great. Okay, the 2's will cancel out, but pause. Hold your canceling out until the very end, bestie. Okay? Really give it a try. Now, all right. So Sprinkle's telling me 4x. Okay, taking a look at this denominator. Okay, if I go like this for a second, just for a moment, so we can get the original. We need to have a common denominator. What's up? What's wrong? What's all kinds of funky? You went to football practice? Well, no excuse. I had basketball. I had no excuse. Okay? Yes, Pog. How are you? All right? If we notice, they're not exactly the same. Over here, my 2x is positive. Right here, my 2x is negative. Here, my 6 is negative. Over here, my 6 is positive. Remember, the signage is always to the left of the number, okay? This minus sign is not attached to the 6. It's attached to the 2. So we need to have a common denominator before we can do anything, okay? So we could multiply, yes, Daniel, we could multiply by a -1, okay? So we could, and when we do pull out a -1, that's going to affect the whole fraction, okay? So let's take care of that. Let me put this in red over here. If I factor out a -1 here, the reason why I need for the 6 to be negative and I need for the 2 to be positive. Whatever you do in the denominator, you're basically doing in the numerator. So this whole fraction is being affected by pulling out that -1. All right? So in actuality, and I'm going to put it up here, this is actually going to be a -6x. Don't worry, we're going to take care of that in a second. And then down here, because we pulled that negative out, all right, now we could rearrange everything in the denominator. So that means the 2x is going to be positive, and just so it can match my other one, I'm going to put the 2x here. And that means the 6 is going to be negative, and I'm going to move the -6 here. So in actuality, what's going on down here is this is a minus a -6x, all right? Then we have our 2x minus 6. Okay. All right, I was a tutor and took math for elective and aced them all, but still forgot. That's all right. It'll come back. Okay. All right, so we got that. Class over now? No, it's not. I'm just reading along to see if anyone had some questions before I move on. Oops. All right, so we got that. We got everything. I'm trying to go to lunch. This is not a lunch class. Yeah, not that. All right, so now we basically have a common denominator, but we could factor this out as well. 2 x minus 3. So they can pair up. So now, what's going on? So we have our common denominator, which is our 2 parentheses x minus 3. But what's going on with the numerator, right? What's happening with the numerator? What's happening with the numerator? Okay, thanks for the follow. All right. Okay, kind of stays the same, but it almost seems like I kind of jumped the gun a bit. I admit when I make a mistake. Okay, sometimes I keep go right into factoring because that's what I've been doing all day. I am not even going to try to lie. Because if I left this as 10x minus 12, I can combine it with this now positive 6x. So if I had it back to its original, I know all this back and forth, but I've been doing a lot of factoring today. So it's just like, yeah, factor, there we go. Like, half sleep doing all that stuff, right? If I combine that 10x, and the reason why it's going to be a plus, because a negative and a negative makes a positive. So I actually will have 16x minus 12. Okay? I kind of jumped the gun with the factoring over here. I'm not even going to lie. So now that I combine my like terms, now I want to factor. Denominator is perfectly fine. What I can pull out with the 16 and the 12, and I think someone said it earlier, I have to take a look to see who said it, is a 4. Okay, that would be my GCF. 2 can work, but then I would have to factor again. So now I have 4x minus 3. Okay, so that means the 16x minus 12, we already took care of it by its factored cousin right here. So now, bestie, this is when we can simplify. Okay, well, hello. Okay, we're working on rational expressions with like denominators. So now we can simplify. 4 divided by 2 will give me 2. And that 2 is going to be in your numerator, okay, the whole number. So what happens up here, that 4x minus 3 stays where it's at. And the x minus 3 stays in the denominator. Okay, you're welcome. All right, awesome. Okay, so one thing, it would have been a lot shorter if I didn't factor from the very beginning. So, hey, I know. I can tell if I screw up, I'll let you know. All right, so when it comes to this problem, let me cover so we get back to the original. All right, so what was in blue was the original. I should have just left it as 10x minus 12. But worked on the denominators first. I noticed the denominators were not exactly the same, so that's why it was the same numbers, but the signs were different. So if I factor out a -1, whatever I do in the denominator, I have to do in the numerator, okay? So basically, this whole entire fraction, aka ratio, is going to be affected with the -1. So that's what made our numerator a -6x, and then our denominator turned into a positive 2x and a -6. And I just put it in terms that it will match the previous ratio. So once we do that, we're going to combine like terms. That's where this part here comes about. with the 16x minus 12, then we factor. Okay, so I think factoring like things like this, factoring at the end will work best. Normally we factor just to cancel out, but that works when we're multiplying or dividing our rational expressions. Okay. Okay. So why the -1? Because if you take a look, 2x here is positive. 2x here is negative. In order for you to add or subtract ratios, aka fractions, you need to have a common denominator. So the denominators have to be exactly the same all the way down to the sign in order for you to combine them. Okay. You got that too? For her class. Okay. Went to football. Okay. Oh, I wish I liked math. It's okay. I think you just didn't have a great exposure to it. It was just the initial exposure throw you off. Someone made you feel like you were dumb and you could never do any of this. And then all of a sudden you developed a label saying that I do not like math because you weren't given the opportunity to like math. See? I know. It's okay. All right. So let's try this one. Let me see if I can redeem myself. B minus 15 over 2b plus 12 minus negative 3b plus 8 over 2b plus 12. Okay. Yet the -1 applies to both the 2x and the 6. All right. Oh, well, thank you. Appreciate that. Is that Luxman? Appreciate that. Honey Maple, thanks for the follow. You miss doing math, Kelly? I know. All right. Well, thanks for the follows, guys. So let's see. Okay, what math is this? This is like a combination of Algebra 1 midway through Algebra 2. Because a lot of students now, and this is like close to the end of the school year for some, a lot of students are now doing rational functions. So their next step was, first was simplifying, and then soon enough, you're going to be solving equations with rational functions. So I think a lot of schools are starting to wrap up with the rational stuff. Yep. Yep, see? Ta-da. Datu's working on it right now. From the second one. Okay. All right. So here's the thing. Let's take a look. First thing when it comes to this, and I'm going to actually see. Step 1, do we have a common denominator? Always ask yourself, do you have a common denominator? If the answer is yes, go ahead and combine your numerator. Remember, we're going to try to save the factoring till the end. And I'm going to show you the steps afterwards. I'm just trying to keep track of everything. So since we have a common denominator, coming over here, write that common denominator once. Don't factor until everything is combined. We're going to save the factoring to the end, okay? So now, let's combine our like terms. Okay, we're subtracting. Now, I know a lot of us are probably like, all right, cool. I got b minus negative 3b. All right, when you minus a negative, that gives me a positive 3b. So that means 3b plus 1b gives me 4b. And everyone does good right there. Then this is when the wheels fall off. All right. Then everyone says negative 15 plus 8. Okay, well, I know 8 and 8 gives me 16, so 1 less, that'll be 7. All right, so my answer is negative 7. It's not. Okay? You always remember doing the subtracting with the first term. But then all of a sudden, I don't know what happened. Body snatchers? Some kind of flick the switch? I don't know. All of a sudden, you totally forget that you were subtracting. So some people like to do keep, okay, flip, or keep, change, flip. Keep, change, flip, or keep, flip, change. Okay? No matter what, you're going to change this plus. So you can write your numerator. I'm just going to write it underneath. Your numerator could be this. B minus 15. Instead of a minus sign, it's a plus sign. And then you're going to change all the signs of the second, the numerator, just the numerator. Okay, change all the signs of the second one. So that means this is now going to be a positive 3b. And now it's a negative 8. Our brains, and I don't know about stuff in the US, we are programmed, even when we were younger, the first thing that we learn how to do is addition. You notice that? The first thing we always learn how to do is addition. We have our counting numbers. The reason why they call it counting numbers is because we count on our fingers, right? So we know how to do addition. And then the next thing that people teach us is multiplication. Then they go backwards to subtraction, then division. But multiplication is just fast addition. So a lot of people feel comfortable with adding, and they feel somewhat comfortable with multiplication, but they're always hesitant with subtracting and dividing. Think about it. It's kind of crazy. So that means we're going to have b plus 3b. Okay, it's not negative 2b. Because when you minus a negative, it turns positive. So it's going to be a 4b. Now we got negative 15 minus 8. Okay? Okay? You can't just do negative 15 minus 8. Yeah, you can. But a lot of people's brains forget about the minus sign when they do the second term. Every time. If you got it, you can remember that, all right, negative 15 minus 8, awesome. Take it, run with it, do it. Okay? But there are some people, for some reason, there's like some kind of switch. They're on it with the first term, but then all of a sudden they lose it with the second. That's why. Okay? So you can still do it. So now both the 15 and the 8 are negative. So that means you are adding. Okay? When they are the same signs, you're adding and you're keeping its sign. So that will be a negative 23. Okay? All right. So now from here, let's take a look. If I factor my denominator, would I be able to cancel it out with anything in the numerator? Okay, thanks for the follow, guys. Thank you so much. Would I be able to cancel anything out from the numerator if I even factor out the denominator? Okay, Pog is saying no. What does B equal? Well, we're not solving. Okay, LeBron, we're not solving. Because if there was an equals to something, then we're solving. Right now, we're just simplifying. Okay, that's the difference. Okay. Eglo says no. YKCF, you're not dividing, but you're subtracting. You're subtracting a polynomial. Okay, you're subtracting a polynomial. So KCF works anytime you're doing any subtracting of a polynomial. It doesn't matter if it's the numerator of a ratio. Okay. Just distribute the negative. It's simpler. Well, yeah, that's what I did with the KCF. This is exactly what I just started doing in math. Okay, good. All right. So we can't, like a couple of you guys said, we can factor out the 2 for the denominator perfectly fine. But we can't factor anything out in the numerator other than a 1. So we're doing all this factoring for no reason, because we can keep this as our answer. That's perfectly fine. Making it sound harder? Yeah, that's fine. It's okay. Because that's why I'm here doing this, because sometimes people make it a lot harder than it has to. But that's what KCF is, base. Okay? Because when you're distributing that negative, right? So that means you're making the signs change. That's why you're going to flip that from a minus to a plus. Because a negative times negative gives me a positive. Boom. And negative times a positive gives me a negative. Boom. Do you have to factor the top as well the same if you do the bottom? You can factor. The reason why you factor is to try to simplify the ratio. If you can't simplify the ratio, it doesn't make sense for you to factor. So that's why I'm saying when you're dealing with these type of situations, hold your factoring to the end. Remember what I did up here? Remember all this shenanigans? Yeah, that was too much because I did the factoring before and then I went back to the original, and that was too much back and forth. Okay? So that's where I made my mistake. So we learn from them. Okay. All right. Well, thank you. All right. Yep. So you can just leave it just as is. Yeah. And sometimes when you're doing multiplication and division, yes, factor first. Okay. All the stuff that we did like yesterday and the day before, if it's multiplication or division, factor first. But addition and subtraction, let's get our denominators right first. Okay, let's get that common denominator right. Okay, all right, so let's take a look. All right, let's do another one. Surprised Michael's not here yelling at me. All right, so let's try this one. So we have 11x minus 5 over 2x plus 5 plus 11x plus 12 over 2x plus 5. Okay, let's build up our confidence. There's Michael. Another one. I know. Okay. All right. I know, Cookie. I know. It's all about entertainment around here sometimes. All right. So 10x minus 5 over 2x plus 5 plus 11x plus 12 over 2x plus 5. All right. Let me leave you be for a moment. Okay, so don't put your answers up. Let me leave you be for about a good minute. Hold your answers for a moment and give it a try. Okay, give it a try. For the previous one, LOL, yes. It was 4b minus 23. Sorry, let me move it over a little bit so you can see. Or do this. Okay, is that better? Oh, this is why, because my fan's not on. Okay, no you're not. Remember, my thing wasn't pushed all the way over, so you're fine. All right, for clarification, if you factor 2b by 2, do you have to do the same for the numerator? No, you factor what is available. Okay, so for this previous one, if you factor out the 2b in the denominator, that doesn't do the same for the numerator. You always factor out whatever the GCF is for each, for the numerator or the denominator. If it happens to be exactly the same, hey, go with it. But majority of the time, it depends on what's going on in the numerator than what's going on with the denominator. Okay. Okay, it's okay, Alice. We're going to make it through. Hello, Tanya. Welcome back. Hey, Jay. Welcome in. Non-hidden figures. Yep. Oh, I could only dream to be that brilliant. Man, one day. Okay. All right, that's what I got too. Okay. All right, so let's see. Go ahead. So we have 2x plus 7 over 2x plus 5. Love that movie. Yes, definitely inspiration. Okay, it's Italian 2x plus 7 and 2x plus 5. 22x plus 7, 22x plus 7. All right. So we have 22x minus 7. Okay, well, let's take a look. So my denominators was exactly the same. So I'm just going to recopy my denominator, just like if I was doing fractions. When we have a common denominator, we just bring it over. Now, since we're adding, okay, we're going to add our like terms together. So 11x plus 11x, that gives us our 22x. Then negative 5 plus 12. So negative 5 plus 12, that gives me a positive 7. Okay? I have $12. I spent $5. I still have $7. So I'm still in the plus. Okay? Aren't alike. I'm going to see if I can go a little bit later. But we'll see. Okay? Oh, Richie, you always say the same exact one. New joke, man. New joke. All right. So now this is where dot two, this is where you come in. So my numerator, the only thing they have in common is 1. My denominator, the only thing they have in common is 1. So I cannot break this down any further. Okay? That's all right, Richie. But see, here's my thing. A lot of other people, it's not always the same people that's on this live. So you know what? I don't want to kill your vibe. I don't want to kill your vibe. All right. Yeah, Soul, how are you? Welcome in. Thank you for the follows, guys. Thank you for the likes. All right, let's try one, possibly two more. Okay, and then we're going to try to sample. Okay. The first one you got right. Good job, Tiffany. All right, Manuel, he says, how come the question before didn't need the denominator? How come the question before didn't need the denominator? What are you saying, Manuel? Let's see. The question before, got it. We didn't need to change the denominators because they were exactly the same. Now, are you talking about us factoring out the 2? I mean, you could factor out the 2, but you're not going to get anything out of it. You're just going to get 4b minus 23. Hey, Lisa. And then if you factor out the 2, you're going to get b plus 6. Okay? Either way, you're not going to cancel out the 4 and the 2 because that 4 is with the b. Okay? It's not 4 by itself. Okay? And then this is a whole entire expression. All right? Oh, the title of this page is Rational Expressions with Like Denominators. Not really. Both of them are considered simplest forms because you can't break down. In order for it to be the simplest form, like if I need to take it further down, that means there's something I factored out that I can simplify. I can't simplify. I'm just redesigning. It's almost like me going out without makeup and going out with makeup. It's still me. You know, it's still me. I'm just, there's makeup and there's not makeup. Okay. All right. Okay, makes sense a little? Okay. With ChatGPT. Hey, ChatGPT is a great resource. Okay. Yeah, so this one was all kinds of crazy. I went a little crazy with it. So if anything, take the first one and then the third and fourth one. All right. Thank you. All right, so let's do one more. And then we'll see what unlike denominators look like. Let's see with this one. So 15x over 5x plus 1. Yeah, we'll put a minus. Okay, I'm going to give you less than a minute for this one. Oops. Did go a little crazy with that. There we go. Okay. Yeah, you can. Okay, so we should be seeing answers about now. Oh, there we go. Ask and it shall be served. Okay. So I'm seeing some 15x plus 3, 15x plus 3. I think we can finally cancel something out. Okay, 15x plus 3 over 5x plus 1. 15x plus 3 over 5x plus 1. We got a 45 over 5x plus 1. Nurses for Carmela. Oh, sweet. Like the name. Okay. Cousin Kira. Hello. Alright. Tanya thinks it's 18x over 5x plus 1. MP7 thinks it's 3. Okay. Remember, question marks are also an answer as well. Okay. Especially if you're just coming in and you want to participate. That's awesome. Do not want to deny that. Okay. Thank you, Soul. Alright. So 3 over 5x plus 1. Got a question mark. Thank you for your honesty. Really, Day? 5 factorial x not equal to negative 1/5? All right, just put a question mark, Day. You're so silly. Okay, how much is my tutoring sessions? Just DM me and I will give you an idea because I need to know what you are in need of. All right, bundles of blessings. How are you? Can we simplify 15x over 5x? Well, let's take a look. Christina says 12x over 5x with 1. Is it Shakita? It says 15x plus 3 over 5x plus 1. I'm doing good. It's been a crazy day, but here we are. All right, so let's take a look. All right, so we have a common denominator. Just like fractions, we're going to keep that common denominator of 5x plus 1. That means we can combine our numerator. We are subtracting. So you have 15x minus a negative 3. When you minus a negative, it turns positive. So you actually have 15x plus 3. Now, some people are saying, oh, we can cancel. That 15x and that 5x, we can cancel. Okay? They're part of a term. Okay? They're a part of a term. If they were just 15x over 5x, yes, your answer would be 3. Okay? Now, you're saying, well, we have a GCF in the numerator, Audrey. I'm like, okay. Your GCF, I'm assuming you're thinking it's 3. Then you have your 5x plus 1. Put it over your 5x plus 1. Now you can factor things out, right? So since this is multiplying, the 3 is multiplying with that 5x plus 1, it's over a 5x plus 1. Because we're multiplying and we have a division, we can cancel those two things out. We couldn't do it here, but because we factored, we have 3 times 5x plus 1. And that was the same as what we have in our denominator, and we can cancel. So our official answer is going to be 3. Okay, you like this? All right. All right. Right, and that's what happens, Sim. That's what happens. Now you're calm. And I know there's a lot of steps. There is. But here's the best thing about these things. This is probably maybe your first time in a long time seeing this, or maybe you have never seen this a day in your life. You're like trying to be firstborn, ready to give a commencement speech at a local college. Like, dude, You got to learn the language, you got to get the tone, you got to get the diction, you got to get all that stuff, right? And you got to have some expertise so you have something to talk about, not like your little niece and nephew that want to talk about 4 different stories all in one breath. Yes, this is why I don't have children. Okay? Because they're like, and then there was a store, and then the foot, and then I had a brownie, and then, you know, life just happened. And then they walk away. Like, what? You just left me in this turmoil. Had me in this story, and then you just up and walk away. This is why I don't have kids. That's why sometimes I look at my friends, I'm like, go get your child. just go get your child. All right. Learning with you. Awesome. Oh, well, hello, Professor. How are you? She's calming, not the math. Yeah, it's the voice. All right. Yes. 3 is not only the common factor. That's what it was for the numerator. Because 3 and 15 multiples of 3. So you factor out the 3. 15 divided by 3 gave us the 5x. And then 3 divided by 3 gave us the 1. So since the 5x plus 1 and 5x plus 1, both in the numerator and denominator, and we're multiplying in that numerator, cancel those bad boys out. And then you have 3 over 1, which is left, which is simply 3. All right. Good. Okay, not a problem. Quick little. Oh, you taught it to your students for today's lesson? Who said that? Sorry, it's not dragging down. Oh, MP7. Yeah, and that's all right. That's okay. We're seeing this. We're seeing it. Should we or shouldn't we? You know what? I think we should. Why not? Let's see what we can do. Let's see what kind of damage we can do when the denominators are unlike. You guys ready for that? Do it. Feel like Mortal Kombat. Finish her. Mortal Kombat. All right. Yes. This is what lack of sleep looks like. Hi. How are you? But because right now I had to turn the fan on. It was getting a little toasty in here. All right. So before we get into it, this is what we need to have a revisit of what LCM is. LCM is the least common multiple. Let me zoom in here. All right, we need to have this down. Okay, now the least common multiple. So let's see if I could let me give us an example. Okay, let me just try to break it down as best I can. So if we have, let's say, 15 m squared, and let's go slow. 15m squared and 18m. Okay, so your least common multiple. A lot of people will say, oh, it is the lowest number because it says least. Not necessarily. Okay. So it's kind of like, what numbers do they have? How should I say? Do they have in common? It's not like the greatest number. Like if I have 3 and 15, the greatest number will be 3. It's almost like if I did, what will give me 15? Let's start with that way. What would give me 15? Let me explain it this way. Okay, 3 and what? 3 and what? 3 and what will give me 15? 3 times what? I'm seeing a whole lot of 3s. They're like, it's 3, Audrey, it's 3. I know. But, so 3 and 5 will give me 15. What will give me m squared? Let's factor all the way out to prime numbers. What would give me m squared if I can break that down? What would give me m squared? Okay, mom. M times m, thank you. Thank you, soul, thank you. What is that? Is that Ariana? Okay, Casey, Deuceby, Bundles, Lisa, Michael. Okay, all right, so we got m times m. Now, for 18, let's think of it. What two numbers multiply, or what would, if I can break it down, what would 18 be broken all the way down? All the way down. Okay? Now you can still break down that 6 and you can still break down that 9. I want to get it all the way down to like prime numbers. So I agree with the 2, but we can break down that 9. There you go, Virginia. Thank you. Bundles, thank you. All right, good. MP7, thank you. Pog, thank you. All right. Did I skip anybody? Yes, I did. See money. Thank you, but you can still break down that 9. All right. Okay. Don Henry, thank you, but we could still break down that 9. Okay. Because break it down into the 3 and 3. So when I say break it down in prime numbers, we can break it down in prime numbers. Now, times my m. So we could look at multiples of the 15s. We could say 15 times 1, 15 times 2, 15 times 3, 15 times 4, so forth. Go with the 15 times tables. Then we can go with the 18 times tables, right? Your 18 times 1, your 18 times 2, your 18 times 3. And we can go and see which would be the first number that both times tables have in common. You can do it that way, okay? But that's going to require your people to know their multiplication tables. They got to know what 15 times past 2 is, okay? Past the 30, what's the next one? Okay? You're 45, what's the next one? And then you keep going, right? So we could do that. Or we can take the numbers that they have. So I notice that the 18, they both have 3s. Now, if you said 3 was your LCM, that's not your LCM. That's your GCF. That's your greatest common factor. Okay? The greatest common factor, believe it or not, is like the reverse of what you think it is. That's what I always thought. Because I always thought like the greatest, that means that's the biggest number. I'm like, nope, it's the other way around. I know, gotta love it when it's reversed. But when we're looking at the least, okay, the least is not necessarily the lowest number. All right? It's not going to be 2. You got to go the other direction, soul. We got to go with bigger numbers. So I see user saying 2 to the power of 3. So 2 to the power of 3, we're looking at 8. The square root of 3. Okay? Candy Girl saying 5. Okay? You're saying 270. 270 is a little high. There's one that's a little lower. That's the least part. Okay? All right, Professor saying 180. I think there was one a little bit lower. That's a little bit lower. Manuel hit it. 99 would be too much. Manuel hit it. It's going to be 90. Okay? It's going to be 90. Yes, Don Henry. There you go. All right. So how are we in the triple digit? What do you mean, how are we in the triple digit? Okay? So if we think about it, let me do it this way. Let me unshrink a little bit. Because I think you're like me. You need to see it. So, if I think of the 15 times table, all right? So, we got our 15, that's my 15 times 1. 30. Then we got our 45. So 15 times 4, add 15 to that gives me 60. Add 15 to this, that gives me 75. Add 15 to this, that gives me 90. Add 15 to this, that gives me 105. I'm trying to do mental math after a full day of tutoring. Yeah, this is funny. All right, so I'm going to stop there. That's the 15 times tables. If I do my 18s, so we got our 18 times 2. Yeah, here we go, 36. Okay, 36. Plus my 18, we got our 54. Okay, 54 plus my 18, or wow. Plus my 18. Times 6 gives 108. I'm going to stop right here. So I could keep going. All right. Thank you. Okay. Oh, Jack. I know. So anyway. So now, since we got all these numbers, we want to get the least common multiple, right? So if I look, the first number that comes along is going to be our 90. Okay? I know that 15 and 18, the greatest common factor is going to be 3. But the least common multiple is going to be the lowest number that first both of them have in their times tables, which is going to get 90. Okay, makes sense? All right. So with that being said, that's going to be my GCF. Got me saying it, LCM. So that's going to be our 90. Now, when it comes to the variables, right away you're going to be like, oh, they have M in common. We're not doing the GCF. We're doing the least common. So that means we're basically adding them together. M to the third power. This is going to be the least common multiple. This is good to know, right? Because when we get into unlike denominators, we got to do something in order to make our denominators common denominators. Okay? So we need to do that. All right? So let's give it a try. So we have so let's say we have x plus 1 over x plus x minus 3 over 3x. Okay. All right, Lisa, have a good one. Do I always add the variables when it comes to the LCM? Yes. Okay, I'm getting to it now. All right, so take a look at the denominator. We have an x over here. We have a 3x over here. So in order for us to add these numerators together, we need to have a common denominator. What's missing in order for our denominators to be exactly the same? I know. Okay, what's missing in order for my denominators to be the same? I think I'll put it this way. It's a lot easier. Right. Thank you, Hope. Okay. Thank you, Michael R. See, you're right with me. All right. Not so much adding a 1 in front of the x, but we're missing a 3. We want to have our common denominator to be the largest. Okay. I could get rid of the 3, but that means I got to take 1/3 of everything. I don't want to do that. All right. It's easier for me to make this x into a 3x than making the 3x into an x. So the way that I do it is, oh, that's not going to work, is I need to multiply this denominator by 3. But whatever I do in the denominator, I have to do in the numerator. Okay? Yes, there you go. By 3 over 3. Good. All right? So whatever we do in the denominator, we're going to do in the numerator. So now, that means this new ratio is going to be, I'm just going to put it underneath, 3x plus 3, because we're not just multiplying the x by the 3, we're also multiplying the 1 by the 3, over 3x. Then we bring down our plus x minus 3. And we get 3x. So now we have a common denominator. So now we can combine our numerator. Keeping our denominator to be 3x. Combine your like terms. Well, thank you. Okay, we're not cross-multiplying, Don Henry. The only way you cross-multiply is instead of a plus sign, it's an equal sign. All right? So what do we get? Yes, 3x plus x gives me 4x. And 3 plus negative 3 gives me 0. All right? Okay, good. All right, so one more step, Candy Girl. One more step, Mike. Michael, you got it. One more step, Bundles. Michael R., you got it. Yes, we can. Okay? The reason why we can cancel out the x's is because this is multiplication up here. This is multiplication right there. So we can just go right ahead and cancel our x's. Because x divided by x gives me 1. And what's left over is 4/3. Okay. Okay, why 4x, Jonathan? Because what's in front of this x is a 1. And you have 3 x's here. Plus 1x will give me 4x. All right, good. All right. Well, 1 1/3 is the same as 4/3. y, what? 90m raised to the third. What? Okay, or you could say 1 1/3. That's fine. Yeah, you're overthinking. Yes. All right. Last problem. Last problem? I don't know what you're looking at. All right. Previous problem. What previous problem? The one above this? All we did was find the LCM, so we weren't even solving anything. Yeah, so all we were just finding was the LCM. Not squared to the third. Oh wait, hold on. Oh wait, there's 2 m's, not 3. You always go with the highest exponent. Thank you. I got scared. I'm like, where are you getting this number from? Yeah. So instead of adding, I think someone asked me earlier. Yeah, so instead of adding the exponents, I am like rough today. You're going with the highest exponent. So when we're finding the GCF, we always found the lowest exponent. But when you're finding the LCM, you're finding the highest exponent. Okay, thank you. I was like, I love hearts. I feel like I don't deserve hearts tonight. Good gracious. All right. I would totally understand if you don't have to. Yeah. 3 cubed. Yeah. So did I. All right. Let me see if I can make it up. So if we have... All right. Slightly going to challenge it. So y minus 2 over y squared plus 4y plus 4 plus, we're going to add these two together, y minus 2 over y plus 2. Okay. You're probably, oh, good gracious, Audrey. It's okay. All right. I appreciate that. Thank you. Okay. Step by step. Now, first thing, we always look at the denominator. So I notice over here we have y plus 2, but then over here we have a polynomial, a trinomial, in fact. So we're going to need to factor out this denominator to figure out what is missing so we can have a common denominator. So let's take a look. My leading coefficient is 1. So I'm going to see if I can just straight split my y's and then ask myself, what two numbers multiplied together would give me a 4 and add together to give me a 4? Okay. Look at you, Miss C. Congratulations. Good. 2 and 2. All right. Give a little celebration to Miss C. Pass her math class. Good job. Yes, yes, yes. Good job. Oh, you're so welcome. You're so welcome. And I feel like I want to say yes. I can't take credit for it. You worked hard. Like, I can't be like, oh, yeah, it was totally on me. Like, no. No, you put in the effort. You definitely put in the effort. Good job. All right. That's awesome. Good job. Love that. All right. Now, oh, hey, Lisa. Have you been here the whole time? I'm just seeing you for the first time. All right. Okay. Not a problem. Okay. Looking at our denominator. I was hiding. I know, right? You have y plus 2 times y plus 2. So that means we have 2 parentheses of the y plus 2. But over here, we just have 1. So that's telling me if I may slide over, put over here, LCM is going to be what both of them need to have, which is 2 y plus 2's. Okay, so that's going to be my LCM. So that's what my second ratio right here is missing. So that means I need to multiply that in. Whatever I do in the denominator, I have to do in the numerator. So that very first ratio is going to stay right where it is because I want to have common denominators. But we can clean up what's going on in that numerator. So, least common multiple. All right. So we are going to do the distributive property. Some of you guys like to call it FOIL. That's fine. But when you call it FOIL, a lot of you guys get so caught up with, wait, which is my first, which is my outer, which is my left, and then you just get lost in the sauce. So what I do is I basically say, okay, we got our y, and we're going to distribute that y to everything in the second parenthesis. So when I do that, I got y times y, which gives me y squared. Y times 2 gives me a positive 2y. And now we're going to take this negative 2 and we're going to distribute it to everything in the second parenthesis. So negative 2 times y gives me a negative 2y. And a negative 2 times positive 2 gives me a negative 4. Okay. Yes, Pog. Good job. Okay. So we got the difference of squares going on in that numerator. Because look right here in the center. They cancel out. One's positive, one's negative. All right. So since one's positive, one's negative, they simply cancel out. Okay, we're combining our like terms. So that means my numerator for the second ratio is actually going to be y squared minus 4. But the denominator is going to be y plus 2 and y plus 2. I know we can say y plus 2 squared. I totally get it, but I like to do my factoring and breaking down at the end. Okay, you never know. You might have something that needs to be canceled out. Just saying. All right. So now I'm going to rewrite my first ratio, which is y minus 2. And remember, we broke it down to that y plus 2 times y plus 2. Okay. Like you guys mentioned, this is a difference of squares. So that will give me, when I split my parentheses, now I'm factoring. I know it feels like you're setting up just to break down. Okay? But would I factor? Because I got to stop myself. I'm so glad I stopped myself because I could have done all that. Right? Exactly. Thank you. Why the problem? I'm adding. I'm not multiplying. So I'm not factoring. All I'm doing is combining like terms. My denominator, it's going to be y plus 2. I might be able to do y plus 2 squared. Okay? Because it's y plus 2, y plus 2. My numerator, I have my y squared. Boom. I have my y plus y. I have negative 2 plus negative 4. So that gives me a negative 6. All right, are we okay so far? No. No what? Yep, so the numerator becomes that. This is beyond me. Okay, it's okay. Yeah, there's a lot of steps to this, and that's what's like throwing it off. That was to a question before. Oh, okay. I was like, what's no? No what? All right. So, is there, because now that we combine, and it's just, there's a lot. The original problem? Sure. Let me see. I'm like, where's the original problem? It just gets crazy. All right. Yes. Deuces. Thank you. Because there are times I have to stop myself because we're so used to factoring and breaking down that anytime we do these, we got to stop and look. Every time you start simplifying, stop and look. And that's what stopped me because you see these parentheses. I was ready to break it down. I really was. And then I stopped and I looked and I was like, oh God, I'm adding. Okay, stop. You're not factoring. Okay. In the initial denominator, the 4 in the initial denominator. Right, okay. What do you mean, up here? From the very beginning? Okay. Yeah. That's where I got off. Okay. All right. So this part here was we were factoring. So since we had that y squared plus 4y plus 4. So once we factored it, what two numbers multiplied together will give me 4, and the same two numbers add together to give me 4. Okay. What happened to the 4y? It's right here. 2 times y gives me 2y. And 2 times y gives me 2y. When I add these two together, it will give me my 4y. Okay? So that's what we did. We factored to get these two parentheses. Once we got this, that's when I said, okay, this is going to be my LCM. That's what I want my common denominators to be. So over here, that y plus 2 was missing one of the two parentheses. We had two parentheses here, but we only had one term here. So we had to multiply the denominator with that y plus 2 so we can have a common denominator. But whatever you do in the denominator, you have to do in the numerator. So then we got into a distributive property. Y times y gives me y squared. Y times 2 gives me 2y. Negative 2 times y gives me negative 2y. And negative 2 times 2 gives me negative 4. Okay. Inside the middle here, that's highlighted, one's a positive 2, the other one's a negative 2. So they cancel out. They give you 0. You don't have to write 0 y because we don't need the 0 to be a placeholder. So what was left was this y squared minus 4. Then, as you can see, I was ready to factor, but rewind, remix it, because we got a plus sign in between the two ratios. We are not multiplying. When you're multiplying, you're looking to factor and to cross out. When you're adding and subtracting, just like a regular fraction, you need a common denominator. Okay? So notice how the trend of adding fractions is the same even when you're doing advanced math. Right? Okay. All right. So now that we have a common denominator, we're going to combine our like terms. Unfortunately, the only like terms we have was the negative 2 and the negative 4. That's where this negative 6 came from. So now we're getting down to this part, which we could factor, because now, where'd my paper go? Oh, right here. If I may, cover all of the shenanigans up and just focus on this part. Okay, let me zoom in a little bit. Okay, so let's just focus on this part. So now, let's see, is there two numbers that we multiply together to give me a negative 6 and add together to give me a 1? Hey Janice, how are you? Thank you so much. Okay, so I got 3 and negative 2, 3 and negative 2. I know you guys are waiting for me to get to that part. All right, so 3 and negative 2 is 3 and negative 2. So if we have, I'm going to write it on here. So we split our y's. We have a 3 and we have a negative 2. So it's a plus 3 minus 2. But my denominator, even if I wrote it out, I got my y plus 2 and my y plus 2. Okay, even if I wrote it out like this, is there anything I can cancel out? Exactly. Will it make a difference? Exactly. Because there's nothing here I can cancel out. I can't cancel out the y plus 2 and the y plus 2 because they're both in the denominator. I can't cancel out the y minus 2 and the y plus 2 because they're not the same signs. So this, or, I'll put it up here, or my y plus 3 times my y minus 2, oops, getting into the corner, over y plus 2 squared, because it's basically the same parentheses written out twice. Either this or this can be your answer. Okay? Either one can be your answer. So it doesn't matter. Because if you can't break it down any further than it is, just bring it down. Right, exactly. Yep, y plus 3, they're together, to death to their part. Y minus 2 up here, together. I don't want to talk about y plus 2 down there. They're those couples that most people in Utah can't talk about. Anyway, I keep seeing it on TV, TLC. It's like, it's driving me crazy. All right. Do math in pen. I know, never mind, right? Feeling like rebellious, especially today. Okay. Can you do the multiplication ones? Actually, Jen, we did those last night. So I'm glad that you said that, because all of my lives, all the lives that I do, are all recorded on my YouTube channel. Okay, so if you go to my YouTube channel and you subscribe, remember, guys, subscription is free. Okay, when I know I say subscribe and subscriptions, people think, oh, it's a paid subscription. No, YouTube, just go ahead and subscribe. I put all of my lives on YouTube for free. Okay, just go to Audrey Codner ACG Math Tutoring, and it's all listed there. Okay, everything from starting from February 5th to last night is listed up there. Okay. How often do I go live? Every day. But I do it once. I had to back it down to once a day because I was doing the morning and the evening, and I was like, this is insanity. So Monday through Fridays, I'm here at 9:30 p.m., Fridays at 1 p.m., and Saturdays and Sundays at 8:30 p.m. All right, so yeah, I come in here. And I will be releasing tonight Audrey's notes. Finally, I've been having so much trouble with the payment links. It's crazy. So for those that are relatively new, if you like my notebooks, I designed this lovely notebook. I just got really sick and tired of my tutoring students not having notes. So what I did was just have a section for them to put their formulas, and for their steps, they can take some of the information. This is from like all this other stuff. And they can actually keep all their notes in one spot. So if they need to know a formula right away, boom, they can just go right to the formula. Plus they get some examples of some problems on both sides of the sheets. This side is grid. This side is dotted because it's perfect for my graphs, as well as, if you're not very strong with multiplication, I do have a factor sheet. Most factor sheets go from 1 to 100. Mine goes all the way to 200. So to help you with factoring, to help you with breaking down radicals, like trying to find the perfect prime combinations, it's all here. Noticing the prime numbers are in yellow and the perfect square roots are in blue. And in addition to those, I have your rules of integers, addition with examples, subtraction with examples, multiplying and dividing. Then we also have the order of operations, properties of exponents. Here we go with some of the linear and quadratic standard form equations, as well as we have a couple reference pages, Pythagorean theorem, SOHCAHTOA, if that's going in there, and also a couple of the trig identities, especially when you get into pre-calculus. Then you have your formula for volume, surface area, area of a sector, area of arc length, okay? Even the equation of a circle is on here. And then last but not least, the unit circle. So using them as a reference. Also, I have a little bit of a brain break. You know, sometimes people just need something mindless to do just to kind of help refocus their brains. And I have these on sale on Amazon. And like I said, I am actually selling copies of my notes. Michael, I finally got myself together. Just the payment link took forever. But got through it, okay? All you have to do when you want to purchase one, because there's a couple things I'm waiting for the state to give me my revised version of my trade name and everything. So that's why I'm not selling on TikTok just yet. But if you click on my picture, go to my profile, go to ACG Math Tutoring. That's my website. You can look up the Ultimate Math Notebook. I have 3 different covers, but the interior is exactly the same. 100 pages that you can use with notes, and then you have the reference part. So this helps with a lot of people that are new or refreshing themselves with math. Now, here's my thing. This is designed for 7th grade to adults. Okay, the reason why I say that is because a lot of notebooks are generally designed for elementary school kids. Okay, if you look on the very back, the multiplication chart, kids just don't know how to read multiplication charts anymore, right? But it gives you that freedom to, if you ever get a piece of paper and you got a couple problems that you want to cut and paste, you can cut and paste them. Okay, or tape them like I do, and you can do the work all to the side of it. Okay, so it kind of gives you a little bit of freedom. You can make it into an interactive notebook. See how you can do a little bit of the graphing? This is why I like the dots, because I can color in my dots so much clearer. It makes the line so much cleaner. All right. And then this is when I was doing matrices and so forth. So all of my notes that I do in my lives, I am selling them. I will be releasing that link and doing some promotional with it. So this is book 3. Book 3 will probably be done sometime, looking at it, probably sometime next week. So you can do a pre-sale with book number 3. But the link of that is going to be going up sometime this evening. Now, watch your live. Oh, thank you. So glad. All right. Thank you, Don Henry. I appreciate that. Yes. Now, if you missed the Pythagorean theorem night, trust me, you could go ahead. Only $99.99. Just $19.99. So if anything, I did Pythagorean theorem. It is on my YouTube channel. Okay, so that video is definitely there and clearly marked. All you have to do is just go to the channel, type in Pythagorean theorem, and the video should pop up. There might be a couple videos that might pop up, actually. Okay, yep. So there might be some stuff that you may need, but I know the collection of notes might help you with your final examinations, because a lot of you guys' finals are right around the corner. Some of you guys have like another 3, possibly 4 weeks. College students, I think you guys are testing your finals either this week or next week. So, but if you want to do some prep work before you're thinking about going back to community college, I'm thinking about having some kind of course. I'm really going to start from the very beginning. I'm thinking about maybe doing it as like a small subscription, but I really want to have something to start from the very beginning, and I'm thinking about starting that in June. If you think that's a good idea, just go ahead and say, yes, Audrey, do it. Or just say, Audrey, don't waste your time. Will I autograph yours? It comes directly from Amazon, but I don't know. I might do that. Because, Michael, you're like one of the OGs to this live. Oh, how I wish I knew when I was in school. Oh. Oh, thanks, guys. I appreciate that. Master's in August, and I'll be bothering you when I get stuck. Hey, go ahead. If it's calculus, I gotta tell you, I got a guy. Like, it's just not gonna be me. Like, I've taught like 4 different math concepts in 4 hours straight. I'm surprised I'm able to put words together right now. All right. You think I should do it? You think, like, would it be helpful? Especially like for people that are brand spanking new, thinking about going to college, feeling a little nervous about it because we know that the course is going to go by rather quickly, because that's like 7 to 10 weeks. And dude, that's a lot of math, and they're shoving it in your brain. So I want to do something as a precursor, a little bit slower, and I'm thinking about covering for about like 3 months. Now, am I stealing your whole summer? No. The way that I teach, I understand the brain a little bit. Like, you want to have practice, but you don't want to be crazy. Usually, if you're doing practice problems, like probably up to problem number 9, that's when you start getting a little cray-cray, right? Things start going all over the place and you're making common mistakes. So if I do give out homework, it's probably going to be like 5 problems, maybe 6. And if you want to do more, I will give you the title that you can look up online, and you can look up whatever you need to look up. I'm not trying to steal your summer away. I just really want you to feel confident in what you're doing. So then when you do go to those classes, you'll be like, oh, I know how to do this. Or if you get stuck, I know exactly who I can go to that can explain it to me. Okay. Thank you. I'm happy that you're here too. For students on summer break. Yes. Yeah. Especially like for students that are going to be transitioning into high school. Like they're going into Algebra 1. Like those are the kids. I'm always trying to go after, and also adults. And it'll just be probably maybe something like this, just like a TikTok live, but it will be actually closed off. So I'm almost like subscription based. So this is the one that's going to be like $5.90 something a month or something like that. So that's what I was thinking about. All right. Yes, you're a math major. Awesome. Oh, well, thank you, Janice. That's awesome. Thank you. Yeah, I've noticed some of my numbers have been going up. Like last night was insane. That was the most visitors and that I've had yet. And that was fun. I looked up at one point. I'm like, does that say 1.3 thousand? Right? Oh, the views was almost 65,000, which was crazy. All right, who's messaging me? And then it was, I looked over at one point and I could have sworn I saw 1.2K, and I'm like, whoa. I know, right? It's insane. And I just started doing this in February. But just the fact that people find some kind of interest in what I'm doing and they find it helpful, I mean, that's just, I'm just here doing what God told me to do. Like, I'm not even going to sugarcoat it. Because some days I'm like, what am I doing? I don't even know. All right. So if anything, there are a couple people, especially the ones that are still here. If you are thinking about going into nursing and you need help with your diagnosis calculations, all right, a blessed RN, she's the perfect person. I like how she structures it. She structures it almost like a puzzle piece. So definitely take a look and follow her. I'm not sure if she's live tonight, yes or no. Impact Math 19, Miss Taylor. She does the TEAS test, ASVAT, GED, similar to myself as well, but she pulls like more problems, more of like the word problems into it. And I know she goes live in the afternoons, 2 o'clock Eastern, but 1 o'clock Central Time. And if you're thinking of a chemistry tutor, if you need one, we got still time left in the school year. So if you have somebody, yourself or maybe your kid needs some assistance, check out Professor TK. And she goes live on Tuesdays and Thursdays at 10 a.m. Eastern Standard Time. And then my friend Lynette, she says she is away at science camp with her kids. So this week she may or may not be on live. But she does learning math with the abacus. And she is amazing. I mean, she is basically, this is a centuries old it's an art form of learning math, adding, subtracting, multiplying, and dividing. And she's basically mainstreaming it. And I don't see anyone else doing this. And I think it'll just be a fun, interactive way, especially with summer coming and your kids are always in your house. And that's all they do is just eat Cheetos and just play video games. All right, like spend an hour with Miss Lynette. Leave the refrigerator alone. Like take a break, right? And then they can learn the cool way to do the abacus. And if they master the abacus, they can actually use that for the SATs and the ACTs when they get older, because it's not a calculator. So they can take it anywhere. All right. So, yeah, I know. I don't have kids, but my friends do. And I'm always like, where are you going? I'm just going to go see what's in the fridge. Okay, did anyone go shopping while you were there 10 minutes ago? No, the food is the same. It's exactly the same. Leave the fridge alone. So, yeah, I get it. So these are definitely 4 people that I've interacted with. There's a couple others that I wanted to interact more with, but they never got back to me. And once I do a follow-up and I don't hear anything after the follow-up, hey, I just like to plug people. You know, I plug greatness. So all that is what's happening. All right, so I'm going to wrap up. Thank you so much for coming out. And I know it's like Cinco de Mayo. And a lot of people showed up here, you know. But please, if you are just kind of nonchalant watching this while you're celebrating Cinco de Mayo, please be safe, be careful, because people are acting froggy right now. I don't know what's going on, but that just needs to chill out. But I will be here tomorrow night at 9:30. I think we're going to be doing a little bit more with this, or I think I wanted to do a couple of the geometry that I'm starting to see people that are taking the ASVAT that I may or may not have addressed. And I think I want to address that because there's a lot of people that are taking the test this week. So I think I might pause on what we're doing with the rational stuff and then jump back on some of the geometry, because a lot of you guys are going to have it for your final exams, and some of you guys are taking the ASVAT this week or next week. So at least I can kind of help with reviewing in that case. Okay. All right. Not a problem, Candy Girl. Not a problem, everyone. Have a lovely evening. And again, hey, go sign up for or subscribe for my YouTube channel. If you're not following me here, follow me here. Just in case YouTube just takes a dip, then you know I'm going to take over when we go into YouTube. Okay, so at least that's going to be the place where you can find me. And if you feel like giving me a Google review, please go ahead and give me a Google review. And if you need online tutoring, do not forget to DM me. Just go ahead and DM me. We'll see what we can do and try to get everything situated, okay? Because I'm slowly about to have more openings, especially towards the end of this week and the beginning of next week. Because a lot of my kids are seniors and they're taking their senior exams either late next week or in the middle of next week. All right, guys. Thank you so much, and I will see you guys tomorrow. Keep being awesome. I love you. Take care.